Okay, so I'm gonna make this video so it's a little shorter in class tomorrow. And you guys all know this from algebra. So the addition property, if A equals B, then A plus C equals B plus C. I can add any number to both sides and they still stay equal. And the subtraction property, if A equals B, then A minus C equals B minus C. That's how we solve equations, right? So, and if A equals B, the multiplication property, A times C equals B times C. Division, same thing. I divide each side by the same number, and they still stay the same. Distributive property, substitution, if A equals B, then A may be replaced by B in any expression or equation. Reflexive property, for any real number A equals A, right? Reflexive, you see it yourself in the mirror. And these are the three, by the way, that sometimes we get mixed up, but we need to remember them. Symmetric, if A equals B, then B equals A. I call this the switching sides property because it starts with an S. And then transitive property, if A equals B and B equals C, then A equals C. Okay? All right. So I want you to try these, see what you get, and then come back and check your answers. All right, so how are you doing so far? What you gotta think about is what changes from side to side, okay? So, what would we do? You could, now this one though is a little different. How did we get AM equals 16? Well, we multiplied, right? So you could say substitution or multiplication property. I think either one of those would fit there. And then, of course, this is distributive. If you got any questions about these, I want you to ask me. Make sure you ask me in class tomorrow. Okay, so this is all setting us up to do 2-column proofs. Okay, the left side are steps. The statements, that should be statements. Sorry, is on the left side. And the reasons justifying each statement are on the right side. What can be used as reasons? Well, you can use definitions. I think I spelled that wrong. Definitions, you can use postulates. You can use theorems. And you can use properties, those things that we just listed on the front. Properties of equality, okay? And we're not going to spend a lot of time on these, but you know how to do these. You know how to solve an equation. You know, what did I do from here to here? I added 1, so this is the addition property. And then what did I do from step 2 to step 3? I divided by 4, so it's the division property. And so on and so on and so on. And we're not going to do any of those. We're going to go straight over here to segments. Okay, so here's your properties of equality listed at the top. And we're going to go over reflexive property of congruence. So these are going to be the same thing as properties of equality, except we're going to use congruent. okay? And congruence is the, means the same thing as equal, except we do it with names, okay? So instead of 3 equals 3, we're gonna say angle A equals angle A, and so on like that. So reflexive property of congruence would be, let's say for segment AB, would be segment AB is congruent to segment AB. Symmetric property would be if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Transitive property, if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. See, they work the same way, but we're just using a congruent mark. We even say this with angles, okay? Definition of congruent, here we go. If A line segment AB is congruent to CD, then AB equals CD. The difference between these two statements is the mark above that and the way we read it. So segment AB equals segment CD, congruent, but the measurement of AB equals the measurement of CD, okay? And if I did this with angles, I would say angle A is congruent to angle B, but the measure of angle A equals the measure of angle B. And it's a little more, I think, obvious how to do it with angles than it is segments. And then if AB equals CD, then segment AB is congruent to segment CD. It works backwards and forwards, okay? The midpoint of a segment divides the segment into 2 congruent parts. So if M is the midpoint of AB, then I know this is congruent to this. And that's how we make a congruent mark. Whoops, AM equals MB. Here's a postulate. A postulate is common sense. You don't have to prove a postulate. We have to prove theorems. So if A, B, and C are collinear, they lie on the same line, and B is between A and C, then I know that AB plus BC equals the whole thing. Piece plus piece equals the whole thing. All right, and then here is just some theorems. And you can look at those yourself. We're going to talk about a lot of them in class. All right, so I think we'll do this page in class. Yeah, I think we're okay there. So I will see you tomorrow in class. That's going to be it.